Assalamu alaikum. I am Omar Farooq, ID 22408016. Today I am present on language models LSTM, short long time memory networks. So without further delay, let me start my presentation. At first, we will see why do you need advanced memory cells. Standard recurrent neural networks process sequences one-time steps at a time and keeps a hidden state as memory. For long sequences, important information from early time steps can become difficult to preserve. This is mainly related to vanishing and exploit gradient during training. LSTM introduced a control memory mechanism using gates. So the goal is learn what to remember, what to forget, and what to output. Now we'll see anatomy of an LSTM cell. It has four gates. In the first gates, that is forget gate, decide which old information should be removed from the cell state. The second one is input gate, decide which new information should be stored. Third one is cell state, carries important information through the sequence. And the final state, output gate, control which information becomes the hidden state or output. At each time steps, the LSTM receives the current input, previous hidden state, and previous cell state. Sigmoid gates produce values between 0 and 1, acting like soft switches. The cell states provides a relatively direct path for long-time information. Now we'll see LSTM gates and cells state update equations. Here is the important equation for these states. Here sigmoid activation 10 is hyperbolic, 10 is element with multiplications. Now we'll see how an LSTM remembers. It has four steps. In the first steps, that is forget steps, remove irrelevant old information. In second steps, that is input, select useful new information. In third steps, that is update states, combine old memory and new coordinate informations. And the final state, that is output steps, explore the useful part as the hidden states. This gated design allows LSTMs to preserve useful information across many time steps. Now we'll see gated recurrent units. Gated recurrent units is a simplified gated recurrent architecture related to LSTM. It uses two main gates, update gate and reset gate. The update gate controls how much previous information is retained. The reset gate controls how much previous information is ignored when forming new content. Gated recurrent units do not maintain a separate cell states. They use the hidden state as the main memory. Because of fewer gates and parameters, gated recurrent units be faster and simpler to train in some stacks. The main idea, it is simpler than LSTM. Now we'll see bidirectional LSTM. A standard LSTM reads a sequence in one direction, past, then future. A bidirectional LSTM uses two LSTM. One reads forwards and other reads backward. The two hidden representations are combined to provide rich context. This is useful when the complete sequence is available before making a prediction. Common uses: speech recognitions, name entity recognitions, sentiment analysis, and sequence labeling. Now we'll see the comparison LSTM versus gated recurrent units and bidirectional LSTM. In LSTM, it has two memory, cell state plus hidden state. In gated recurrent units, it has one state, hidden state. In bidirectional LSTMs, it has two bidirectional hidden states. In LSTM, it has two gates, forget, input and output. In GRU, it has two gates, update and reset. In bidirectional LSTM, it has LSTM gates in both directions. The complexity of LSTM is higher. The complexity of GRU is lower, and the complexity is bidirectional LSTM higher than single LSTM. In LSTM, the context is past context. In GRU, the context is past, but in bidirectional LSTM, the context is past plus future context. The efficiency of LSTM is long dependencies. In GRUs is efficiency, and in bidirectional LSTM, full sequence context. Now we'll see practical applications. It is used in time series for forecasting, speech recognition, natural language processing, sequence labeling, text predictions. Model choice depends on data size, sequence length, legacy, available context, and compute budget. Well, now we'll see practical benchmark and evaluations. Time series forecasting. Evaluate using mean average error, mean square error, root mean square error, or mean average percentage error depending on the problem. Speech recognitions. What error rate in a common matrix? Classification. NLP tracks accuracy predictions, accuracy precision recalls, and FI score are widely used. Compare LSTM and GRU under the same dataset, pre-processing, training, budget, and evaluate split. For bidirectional LSTM, remember the future context is available only when the full important sequence is known. A model with higher accuracy is not automatically better if it is much slower or more expensive. Now we'll see key takeaways. LSTM solves many long-term dependency problem of basic recurrent neural networks through gated memory. The forget input and output gate control information flow through the cell. Gated recurrent units provide a simpler alternative with fewer gates and no separate cell states. Bidirectional LSTM capture information from both past and future direction when the complete sequence is available. LSTM family models remain important for time series, speech, and sequence processing tasks. The best architecture should be selected using both predictive performance and practical constants. The overall summary or final message is good memory plus control information flow equal better sequence modeling. Thank you all for hearing me.